Remember that we split 5.4 into two sections. 5.4a, we were just adding and subtracting. And today we're going to be multiplying and dividing, and we're going to plot complex numbers on a plane, which isn't as hard as it sounds. But does anybody remember what a complex number looks like? Complex number was in the form a plus bi. The a was the real part. The bi is the imaginary part.
I can't see.
There you go. Okay, and when we want to write complex numbers, and this is called standard form, we must always put the I at the end. Okay, so if you start working the problem and I ends up at the front, you just move it to the back. Okay, because we want the real part to come first. Okay, so what we're going to be starting with is just some examples. So example 1. I times 9 minus I. What do you think we're going to do here? Yeah, we're just going to distribute. So we distribute the I into the parentheses. And we are going to get I times 9 gives me 9I minus I squared. Well, is it? Do we know something about I squared, right? What does I squared equal? Negative 1. So we're going to replace I squared with negative 1. So we get 9I minus negative 1. And in this problem, I have minus and negative, so what happens? Everything becomes positive. So I would get 9I plus 1, but is that in standard form? No, we want the i's at the back. So this 9I is a positive, so we can just rearrange the numbers to become 1 plus 9I. And that's my answer. Example 2. 3 plus 1 times, or 3 plus I times 5 minus I. What does this one look like? Not distribution, it looks like FOIL. So let's FOIL it out. You can use the boxes if you're more comfortable with the boxes. Okay, so we just multiply. 3 times 5 gives me 15. 3 times negative I. Negative 3I. Positive I times 5 is plus 5I. And positive 1 times negative 1. Negative, we're multiplying. Negative I squared. You can do the boxes if you want. Okay, now I can combine like terms, right? Negative 3I plus 5I, what does that give me? Positive 2I. And I also have minus I squared. What does I squared turn into? Good, negative 1. Am I done? No. Minus and negative becomes positive. So we get 15 plus 2I plus 1. And what's 15 plus 1?
16.
Good, 16. So 16 plus 2I. And then we're done. Example 3. Come on. 5 divided by 1 plus I. Now we have something in here that is a big no-no in the denominator. What's in that denominator that we don't want? An I. So how do we get rid of it? Do you guys remember? We multiply by the what? We don't.
1 plus I.
We don't multiply by the same denominator. We multiply by what's called the conjugate, which is going to be 1 minus I. Okay, so we multiply the numerator and the denominator by 1 minus I. Okay, and so then what happens? In the numerator, we're going to have 5 times 1 minus I. And in the denominator, we have 1 plus I times 1 minus I. How do we simplify the numerator? We distribute the 5 in, so that's going to give me 5 minus 5I. And what about the denominator? Good, we FOIL. So 1 times 1 gives me 1. 1 times negative I is minus I. Positive I times 1 is plus I. And positive I times negative I is negative I squared. Now this is exactly what we wanted to happen because... It's an I.
No, go next to it. Go left. Yeah.
It's an I.
Too many eyes.
Okay, now this is exactly what I wanted to happen. I have negative I plus I. So what's going to happen there? They cancel out. So what do we have in the numerator? 5 minus 5I all over 1 minus I squared. And we know something about I squared. Some of you are already saying it. What is it? Negative 1. So this is going to change. I'm going to bring it down here. 5 minus 5I all over 1 minus negative 1. Minus a negative, everything changes to positive. So this is 5 minus 5I all over 2. Now, a lot of times you would be able to stop here. If we were doing like quadratic formula, we would stop here, right? But when we're dividing this whole numerator by the denominator 2, what are we really doing there? We're dividing 5 by 2, and we're dividing 5I by 2 also, right? Both of these terms are being divided by 2. So what your book does, and I just want to do it to stay consistent with the book, they split these up. So we can split this up as 5 over 2 minus 5I over 2. Because we want it to be in standard form, which means they have to be separate, right? So we need to rewrite your answer as 2 separate fractions, and that way you can reduce also if you can. So this would be your answer.
How'd you do that?
Okay, this time we have 5 plus 2I all over 3 minus 2I, and I have an I in the denominator, which is something I do not want. So I need to multiply the numerator and the denominator by the conjugate. Okay, which means that we change 3 minus 2I to 3 plus 2I. Okay. So we're going to actually need to FOIL in both of these problems. 5 plus 2I times 3 plus 2I all over 3 minus 2I times 3 plus 2I. So let's FOIL. That's going to give me 5 times 3 is 15. 5 times 2I is positive 10I. 2I times 3 is positive 6I. And 2I times 2I is positive 4I squared. All of that over. And then we FOIL again. 3 times 3 gives me 9. 3 times 2I plus 6I. Negative 2I times 3 is negative 6I. And negative 2I times positive 2, negative 4I squared. So all I did was I FOILed the numerator and the denominator. I multiplied them all out. Let's combine like terms as much as we can. So in the numerator, we have 10I plus 6I. So that's going to give me 15 plus 16I plus 4I squared. over 6i minus 6i. What happens there? They cancel. Good. So we get 9 minus 4i squared. Exactly. So we know something about I squared. I squared equals -1. So I'm going to change those I squareds to -1. So the numerator is going to have 15 plus 16i plus 4 times -1 all over 9 minus 4 times -1. And so then what happens there? 15 plus 16i, positive 4 times -1 is -4 over 9 plus 4. And we can combine like terms again. We have 15 minus 4, which gives me positive 11 plus 16i. All of that over 9 plus 4? 13. Okay, quick question. Is this in standard form? No, we need to break up that denominator. So we're going to break it up, and we get 11 over 13 plus 16i over 13. And this would be my answer. The one thing we have to know about plotting imaginary or complex numbers is that each complex number stands for just one point.